Hello, just wanted to make this quick video to share something I found out about my Samsung RS21 something fridge freezer. I recently got a smart electricity meter in my home so I can see how much electricity is being used, and I discovered that this fridge freezer was using twice as much as it's supposed to. I found in the manual it says it's meant to use something like 520 kilowatt hours per year based on that, but this was using twice that much. However, it was able to maintain its temperature, so let me first just quickly say, if you're looking for a solution to why your fridge can't actually maintain its correct temperature, this video is probably not going to help you. But if your fridge is like this and it seems to maintain temperature, but it's on a lot of the time, you know, it goes click and brrr, but it does that for a long time, then I might have a solution as to why that is, and it's part of the design, which is just stupid on these fridges. And the quick thing to check is to come around the back while it's on, take the panel off, and then just run it for a while and see if that fan there spins when the compressor's on. You can see this is the compressor, this is the condenser, which for those of you who don't know is very much just a radiator which allows the heat pumped out from the fridge and the freezer to be dumped somewhere, which is into the room. And it's got a fan there to blow on it, and that is very necessary, but it wasn't turning on mine. At least I was a bit confused at first because it didn't turn on, then it did turn on, and then it didn't turn on, and I spent ages trying to figure out why. And actually it's part of the design, it's just stupid, and it's absolutely necessary to have it on to run properly, because as you can see, you know, unlike traditional fridge freezers which might have a big grill of radiator right across the back to let the heat out, this one is quite a neat solution. It's just got it in this sort of compartment at the back, and the condenser, the radiator, is actually all kind of coiled up on itself. You can see there it's sort of going round and round inside itself. And not only that, but it's in, you know, it's in the box at the back. As I'm sure all of you know, heat rises, so the heat tries to come up, and where does it go? It just gets stuck in this enclosure at the back. Sure, there's a few grills on the thing here, but you know, especially because it's all rolled up on itself there, it absolutely needs the air forced through it to be able to dump the heat out. And I spent ages trying to figure this out, but eventually I found a little bit in the Samsung service manual for this fridge, which I'll link in the description, which said if the room temperature is 15 degrees or below, it will never turn the fan on. And I think if it's below 19 degrees, it'll turn it on, but only with like a 5-minute delay or something like that. Which is nuts. It's absolutely nuts and crazy, because as you can see, it's all coiled up on itself here. It really needs the air forced through it to dump the heat out. So I don't know what they were thinking, but that's it. So, yeah, check that the fan runs. There's a sensor for the room temperature, which is in the top left hinge. Let me show you. It's on this, underneath this cover here, there's a little sort of white cylinder with 2 wires going into it, and it senses the room temperature. You just take that one screw off and you'll be able to find it, but it doesn't really help you to be able to find it. The connection comes down to the electronics brain box, which is inside this white case here. And so I'm going to put the camera down and take that white brain box out and open it up. It's just got a few clips on the back. And I'll show you how to fool the brain box into thinking the room is warmer all the time to make it always turn the fan on. And by doing that, the electricity usage drops by more than half. So yeah, quite important modification, unless, you know, if your room's always 19 degrees or above where you got the fridge, it probably doesn't matter because it'll always turn the fan on. But yeah, like I say, take the back panel off and just watch it for a while and see if that fan regularly turns on, because if it's not turning on when the compressor kicks on, or if it's turning on but with a 5-minute delay, then you're basically wasting electricity. So I'll show you how to do that in a second. Okay, here we are. Here's what's inside the electronics box, the brain box. And this wire here is the one for the room temperature sensor. It says on the board there, external sensor or something like that, I think. Yeah, EXT sensor. So this whole board is quite nicely labelled, and it's easy to take out. There's a bit of plastic clip that you press here, and then you can just pull the board out. Now we can extract the board, and on the back it's even got printing on the back to help you see what's going on. This is the sensor here, and you can see I literally just soldered a 10k, a 10 kilo ohm resistor across those two, where the two wires go in, and that will make the computer box there think that the room is always warm enough to be worth turning the fan on. And yeah, that dropped my electricity usage on this fridge by half. Okay, now there's something else worth checking out as well. This capacitor, this big capacitor here, actually that's a replacement one. The original one is this one. It connects to the compressor motor and helps it run properly. But I found this one was completely worn out. It says here that it's meant to be, come on, focus, meant to be 5 UF, 5 microfarads, but I've got a capacitor tester, and this one was 1.5, so like 80% or something out of spec, massively out of spec. So I bought a new one, quite easy to do. This is from the company RS Components. That's the component number there if you want to get the same one. But you just need a 5 UF capacitor suitable for running motors, high voltage, safety rated, all that kind of thing. And it's just got these push-on connectors there, and it just goes back in there. And but I have to say, I didn't actually notice very much difference in the efficiency when I changed that. I thought I would, but I didn't really. But I did notice a big improvement in what's called the power factor. Excuse me. Power factor is not really to do with how much electricity is used, but it's kind of a measure of how easy it is for the power grid to supply the power to the device. So especially for devices like this, like a fridge, which are going to be used in, you know, millions of homes probably, the manufacturers kind of have a responsibility to make sure that their equipment is easy to supply for the national grid. Otherwise, if loads and loads of people have equipment which draws power in a way that's not going to be easy to supply, then it you know, it makes, well, it costs a lot in sort of infrastructure and power factor correction equipment for the national grid. So this capacitor just makes sure that the power factor, the way the fridge draws power, is nice and easy for the national grid to supply. So it is worth keeping, getting it right. And I think this one from RS Components cost about £4, so you know, it's not a lot to spend. And you just change those, just swap over those two wires. Actually, this, because it's a modern capacitor, you know, the other one's probably 10 years old, it's actually quite a bit smaller for the same capability. So this clip is meant to hold it in. I'm probably going to wrap a bit of cardboard or something around there with some tape to just bulk it up a bit so that it can hold tightly in there. Yeah, and there you go. That's it, really. If you find that your fridge works, but it always seems to be on a lot and using a lot of power, well, it's worth coming around the back and seeing whether the fan's turning on regularly, because if it's not, either the fan's broken, or quite likely the computer brain box there is thinking that it's a good idea not to turn it on, because it's just a stupid design.